The round hole is where the air comes from at the back. There is a turn flap on it to control the air volume. The air goes through this hole. After the air enters through this large hole, it will be divided into 4 channels to go to our 4 cylinders. On top of the small air inlet, there is a flip flap, which is currently in a closed state. Our airflow enters from the upper side of this flip flap. This method is used for low-speed operation. When our engine is running at a high speed, for example, when you step on the gas pedal, a large amount of air is needed to fully open the flaps. This is what it looks like when it is opened. Doubled in size, there is also a system on the side of the air duct can be pulled down to open the doors. The engine computer sends a signal to this mechanism to tell it whether the intake air duct should be open or closed. On the other side, here is a sensor monitoring which measures the angle at which the flap inside is open. After detecting this signal, it will provide feedback to the engine computer. This is a closed-loop control. Let's first disassemble the position sensor on this side. The head of this sensor drives the green part, and when it rotates, the resistance value inside will change. When the engine computer receives the signal, then we know exactly to which angle our flipper has rotated. You can see the control mechanism here, and this was removed from the car. So there is also a pipe on this side that leads to the back of the throttle valve. Behind the throttle valve, there should be a negative pressure. We can simply understand that this side it is constantly sucking air out. It means that the link is being pulled into a drum, it is being pulled inside. When not sucking, then because of the spring, it comes back again. This rectangular thing is an electromagnetic valve, which acts as a switch to open or close the suction passage. This electromagnetic valve is controlled by our engine computer. It has 2 connectors. When the engine computer sends it voltage, this electromagnetic valve opens with a click. The vacuum tube road is now open. Let me give it a try for everyone now. Now we will use 2 wires to connect to this terminal in order for us to power it later. I have connected the positive and negative poles over here. At this point, all I need to do is connect this positive pole, and later we will listen to its sound. Actually, if we keep it connected continuously, it will remain in an open state. Why does it retract when the vacuum is drawn here, and the lever can move back? We are using a slightly forceful method. We have already opened up this drum. This vacuum tube is being evacuated through this small hole, while on the other end of the spring, you can see a thin sheet that can separate the drum into 2 chambers. But once we put the drum back together, the force of the spring will push this rod forward. So when our vacuum tube breaks and the atmospheric pressure is restored inside, it will bounce back again. In fact, this is a common problem with the EA888 engine. Here, this ball head has already become loose, including the shaft. It can freely move in and out of the Passat. And there are many cars from Volkswagen's CC series that also use the 2nd generation EA888 engine. If you are driving and the car is shaking at low speeds, and if the check engine light is on, you can ask the gas station to check your throttle plateau, see if there is an issue. If the shaft is slightly out of place, it can cause this problem. Your air will leak from this place, causing the engine to shake.